Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on orbital spacecrafts. So, in this module we are discussing the neutral environment and its effects on the health of the spacecraft. So, if you remember, we discussed the various categories of the neutral environment. So, we discussed like microscopic environment. In microscopic environment, we discussed the atomic oxygen and its effect. Then there is macroscopic environment, orbital debris and its effects. So, the effect of the atomic oxygen on the material, on the surface, on the various materials of the spacecraft, like those materials which uses the polymers, as well as we have seen that is the residual atmosphere, though it is very thin, the density is very low, it is like vacuum, but still it plays a significant role in the orbital parameters of the spacecraft. Means it changes the orbital parameters like the altitude and its orbit. The other topic we discussed, that is the micrometeoroid or the orbital debris environment, and there is one phenomena which happens here, that is the hypervelocity impacts. Means the velocity, when the velocity is something like 3 km per second to some few tens of kilometer per second. So, this is called the hypervelocity. Now, any particle with moving at hypervelocity, when it impacts of the spacecraft, it creates a lot of the problem, and we have seen that depending on the size of the particle, whether it is a submicron or it is having or it is some few microns or few millimeters, the impacts are different. So, we have seen that is what is the hypervelocity impact in terms of physics also we have seen. So, we have considered the plates where the thickness of the plate versus the radius of the we have considered a spherical particle. So, when the ratio of this particle, that is the ratio of the thickness of the plate versus the radius of the or the diameter of the impacting particle, when it is very small, when it is very small, then there is the the impact, it creates a cut, or we called it a cookie, it is just a cookie cut, or it can happen if when the size, when the thickness increases, then depending on the various material properties, the impacting particle can melt and it can give rise to the spall, means damaging the thing and taking out the material from the back side of the plate. So, these are the things we have seen in the last session, and we have seen some mathematical two mathematical models also we discussed, and then we discussed the shielding mechanism, and we discussed that is how it can be done by either a single plate or the multiple plates. We discussed a very simple that is the Whipple shield consisting of two plates. So, one we call the bumper plate, and the other the plate is which is the skull of the spacecraft. So, we will proceed further, and today our topic will be, we will discuss, so far as we were discussing the spacecraft environment is the ambient environment, means the ambient parameter is specifically it is orbit limited, but the spacecraft itself can generate some it itself can generate the particles, that we will see how it does, and then we will discuss the topic, the scattering of the electromagnetic radiation from the particles, and as a result of this scattering, what happens to the various subsystems and how it is not a desirable phenomena. Then we will just though we have this we have mentioned a number of times the orbital debris, but a systematic discussion of the orbital debris we will start today, and maybe we will continue in the subsequent sessions. So, what is spacecraft induced neutral environment? So, the neutral environment as I already discussed, that it includes the ambient. Ambient means it is what is there already there in the orbit, and the other one is the self generated. So, self generated means sometimes these spacecraft induce their own environment. Now, how it does it? So, the release of the neutral gas from these sources on the. So, as you already know that we discussed when we are dealing with the vacuum environment, that there is the outgassing. That outgassing happens because of the that outside pressure of the spacecraft is very low, it is vacuum like. So, because of that thing it the spacecraft it release the absorbed gas when it is exposed to the space environment, because the ambient neutral gas pressure in space is very low, it is like vacuum, it is near vacuum environment. To that what is there in the earth. So, earth we are having the atmospheric pressure. So, since there is no atmospheric pressure, the pressure is very low. So, the spacecraft itself can release the gases because of the outgassing. This is one effect, one way it can do. Additionally, the materials can release gases through decomposition and sublimations. Sometimes there may be some materials which creates the gases, it can be solid, but because of the material properties it can add to the or it can release the gas because of this sublimation. Then neutral gas can be generated through backflow from the thruster fairings. The thruster fairings are used for the attitude and orbit control system. Then it can be the incomplete ionization of the ion thrusters or the whatever the electrical thrusters are used. So, they are also because of the it can also release the neutral gases because of the incomplete ionization. Now, over time these gaseous products can coat and contaminate sensitive sensors and surfaces, seriously degrading their performances or rendering them useless. We will see, but I am just stating here that optical sensors may be affected on the payload as well as the thermal control surfaces and the whatever the cover slides are used in the solar arrays. All these things can be badly affected because of the even this when the spacecraft when this spacecraft itself generates the environment, which is also called as the contamination. Spacecraft can contaminate itself, can contaminate its own payload. So, let us see that is what are the concerns due to the induced particle environment. So, space based optical payloads. So, here the particulate contamination induced by the orbiter and its subsystem. So, what happens this type of contamination originating from the dust particles, it can be the flakes of paint and other surface products, it can be the droplets of propellant, or it can be the ice particles resulting from the cabin leaks, vehicle outgassing, water releases, and the that is the effluent or the waste dumps. So, these manifests itself by scattering sunlight or the EM radiation and emitting radiation into the field of view of the detectors of the optical payload. So, this introduces spurious signals from the resolved particles and causes a general increase in the background brightness from the unresolved particles. So, this means that this optical payloads it will not able to resolve the particles because of this scattering by this contaminated particles near the optical payloads or on the mirrors. It can be on the it could have contaminated the mirror itself. So, that time you get this type of issues. So, in some cases it can even result in the loss of the valuable scientific information. For example, if you consider the case of a infrared telescopes. So, it can create a serious problem for the IR telescope. A sensitive IR telescope on orbiter may be limited by its performance by the fluctuation in the IR radiation from the natural environment and the contaminant atmosphere or the environment. Now, we will see that is the scattering of electromagnetic radiation from particles. So, we will consider here the in general as well as the particles which are the ambient particles as well as those which have been induced by the spacecraft. So, scattering of electromagnetic radiation from the particulate environment around a spacecraft is very important phenomena. When we consider the space mission and the space observation, even the satellite operation, like we will see that for the satellite operations, we need the star trackers or it is called the star sensors or the earth sensor, and these are basically these payloads are optical payloads. So, it creates a lot of problems. So, it can create problem for the satellite operations, and then we will see that even the deep space exploration. Deep space means when we are the space, it is beyond the earth and the moon, or when we are going to the interplanetary space, it is called the deep space. So, particles in the environment such as dust, then micrometeoroids or even gaseous molecules can scatter EM radiation. So, impacting the performance of the sensors and the communication system on spacecraft, we will see one by one. So, particulate contamination in the vicinity of spacecraft may interfere substantially with electromagnetic observations in the ultraviolet, then visible and the IR regions of the spectrum. The optical scattering from the particles, even as I already said, it may result in the tracking errors of the star sensors. Now, let us see what are these the sources of EM scattering. So, already I said that is the space debris. So, a major concern of the spacecraft, especially in the low Earth orbit, is the scattering of EM radiation by the debris surrounding the spacecraft. The debris can scatter light, causing issues with the optical system that already we have seen. It can be the other type of sensors, like it can be a IR sensor or in a UV sensor, and also it creates problem for the communication system. Then the dust clouds in deep space. So, in the regions of the space where the dust clouds or that is also called the interstellar medium ISM are present. So, there also the scattering can affect both visible and the radio wave communication system. The Earth's atmosphere. So, for the spacecraft observing Earth, the scattering of the sunlight by atmospheric particles, it can also distort the data collected by the remote sensing instruments. Now, we will see what are the types of EM scattering by particulate medium. So, this is called the relic scattering. These are the different the method by which this scattering is analyzed. So, one is the relic scattering. What is relic scattering? When the wavelength of the EM radiation is much larger as compared to the size of the particles. So, this is most relevant when the particles are very small. So, this can be the gas molecules or the nanoparticles. The second is what is used is called the Mie scattering. So, here when the particle size is comparable to the wavelength of the radiation. So, this is called the Mie scattering. So, here what is done, it is often observed for the spherical particles like water droplets, the dust and other aerosols. So, Mie scattering theory, it is the generalized solution which describes the scattering of an electromagnetic wave by a homogeneous spherical medium, having the refractive index which is different from that of the medium through which the wave is traversing. The third one is that is geometrical optics scattering. So, this is applicable when the particles are large compared to the wavelength. And this cause the diffraction, the reflection similar to what happens with the optical phenomena in the macroscopic world. So, generally these two are important for that is the electromagnetic scattering by the particular particulate medium, that is the relic and the Mie scattering. So, the scattering model and theories. the Rayleigh and the Mie theory. So, these two are used to predict how the intensity and the direction of the scattered EM waves they change with respect to the properties of the particle. So, this is very important. If you want to analyze how the scattering happens, then you need the mathematical the scattering, that is the electromagnetic modeling. So, this and the properties which are used in the model, that will be what is the size, what is the refractive index and the wavelength of the incident radiation. There are some this is a numerical method, that is a computational that is the electromagnetics method, that is called the transition matrix or tree matrix method. So, in this approach to study the scattering by non-spherical particles. So, essentially here the Maxwell's equations are solved numerically by matrix method for the irregularly shaped dust grains or the particles in space. The other one is also, this is an analytical method, this is called the discrete dipole approximation DDA. Used for the modeling of the scattering from particles that are irregular in shape. Similar like this method, this is a numerical method, this is basically an analytical method and which are common in space environments. We will not discuss much detail about all this method, that is the scope of this course, but these are the methods which are used. Now, what are the effects of this EM scattering? So, when it is a thermal radiation scattering, so the scattering of the thermal EM radiation, it can be infrared from the particulate environment, can lead to the heating of the spacecraft surfaces or instruments. Then it can be optical and visible radiation scattering. This already we discussed, that is the micrometeoroids or debris in the space can scatter visibly, can scatter visible as well as the UV radiation affecting the optical instruments or even influence the surface properties of the spacecraft. Now, this is something which we will see maybe in our the next sessions when we will discuss the plasma environment. So, here what happens, the charged particles from the solar wind, this can interact with the spacecraft surfaces and this can this scatter the EM radiation. Potentially it will affect the sensor readings as well as the spacecraft operations. So, here the scattering is not by the neutral particles, but the charged particles. So, we will see what are how it impacts the different spacecraft systems. So, this communication payloads, so the scattering can distort or weaken the signals transmitted from or the or received by the spacecraft, because always there each and every spacecraft, whether it is a spacecraft in Earth's orbit or it is the spacecraft is there in the deep space, we need to have a communication that with our whatever the ground stations are there on the earth. So, this type of scattering what it can do, it can change the signal amplitude or it can attenuate the signal as well as can changes the phases of the signal. If the phase and the amplitude of the signal is changed, so in that case whatever the information contained by the those signals, especially the digital signals, it will be impacted. And then getting a information at the receiver at both, whether it is on the spacecraft or it is on the ground, it will become a challenging task. So, it can impact the overall data transmission. The second is optical instrument and sensors. Of course, this point already we have discussed, we will not say it again. Now, third issue is that this is a radiation pressure and dust impact. So, what happens when the particles, especially for the larger particles or in the dense environment, the scattered EM radiation, it can generate a radiation pressure. What is basically a radiation pressure? So, radiation pressure is something like that whenever a surface is exposed to the radiation, or you can consider like the photon. So, it creates a pressure, it is a mechanical pressure on that object. So, what it can does, because of this the spurious the EM radiation, because of the scattering by the particulate environment, it can give rise to the radiation pressure, and which will exert forces on this spacecraft, means it will change the it can change the attitude of the spacecraft. Similarly, the dust particles themselves can impact the spacecraft or its instruments, potentially damaging them. So, these are the various impacts of the EM scattering or by the particulate environment. Then there is one more effect, that is the thermal effects. So, the scattered radiation can heat up the surrounding particles, especially in the infrared range. This can affect the spacecraft thermal environment and heat management system, because whenever there is the change in the temperature, if these effects are not considered during the design stage, so this may create problem to the thermal management system of the spacecraft. Now, we will discuss a few mitigation strategies just to combat the scattering of EM radiation in the particulate environment. So, for that it is very much needed to understand the type of scattering, what are the impacts on the spacecraft systems, and then in order to do all these things you need the appropriate mathematical models, then you need some mitigation strategies depending on this space mission. So, one of the mitigation strategies is to use proper shielding. So, spacecraft are often equipped with shielding to protect sensitive instruments from dust impacts and scattered radiation. So, this shielding can reduce the risks of damage from the particulate matter. Then design of sensors and the instruments. So, in the some instruments are designed, it can be designed using various types of the filtering technique, so that it can minimize the effects of the scattering. As for example, some optical sensors can differentiate between the scattered light and the desert signals. Then you can use the adaptive algorithms. So, signal processing techniques which use the adaptive algorithms. So, this can be used to mitigate the effect of the scattered radiation by compensating from known distortions. So, these are the various techniques which are generally employed. Now, we will start a new topic that will discuss more details in the next session. Just I will introduce it here. So, orbital debris already you know what is the what it is. So, these definitions are known. So, what is debris means it is no longer doing any useful services, and it poses the collision risks to operational spacecrafts and the international space stations. So, why it is a problem? Because the collisions can create more debris. So, this is called the Kessler syndrome, means what the Kessler syndrome says, that this debris, whenever the debris there is collisions, and so it will create more debris, and over the time. So, this increase in the debris it is exponential. So, this is called the Kessler syndrome. Then risks to the astronauts, then satellites and space infrastructure, then growing the number of satellites. So, this number of satellites in the low Earth orbit especially, it is increasing really exponentially, like the star link, whatever the constellation of satellites, they are planning to put some 42,000 of satellite in an orbit of something like 400 to 450 kilometers. So, this itself is very the challenging in terms of the increase the congestion or the debris. So, classification of the debris, here also like the way we classified the the material like from the micron to few centimeter. Here also similarly there are the classifications are there based on the size and what are the types. So, when what is the origin? So, if it is by the fragmentation, then it can have from the explosions or the collisions, then it can be non-functional spacecraft. So, it can be decommissioned satellites, it can be out of control spacecraft, then it can be rocket bodies, then it is spent upper stages left in orbit, then mission related debris. So, mission related debris means there are various mechanisms and these things are used. So, those parts can be released during the launch operation like the clamps, then insulation, bolts, all those things. Now, by size, so this it can have, we will call the debris a large size debris when the size is more than 10 centimeter. So, it can be the dead satellites or the rocket bodies can be tracked by ground radar and avoided. So, if the target is if the debris is more than 10 centimeter, it can be detected by multiple target of multiple object target radar. So, this type of is possible to do and it can be avoided, but when it is medium something like 5 mm to 10 centimeter, this comes from the fragmentation debris which we discussed in the last slide, and these are very hard to track, especially from the ground you cannot do it. It can be tracked from the onboard the sensors, but these are the tricky to track them, and this becomes dangerous to the operational spacecraft system. Small, when it is less than 5 mm, it is called the small. It can be the paint flakes or metal fragments. These are not traceable or not trackable, and those can penetrate the spacecraft surface because of the hypervelocity effects. Of course, all these debris types will have the hypervelocity effect. So, I will conclude it here, that is the whatever we discussed is this induced environment of the spacecraft and the EM scattering, especially by the particulate environment. So, in the next session we will continue with the debris only. We will discuss what are the difference the the debris management schemes and what can be done. So, all this topic I will be discussing in the next session. Thank you very much.